Today we'll finally be able to take a look at the performance of Intel's new Arrow Lake CPUs, also known as Core Ultra 200S series of processors. So this will include CPUs such as the Ultra 5 245K, Ultra 7 265K, and Ultra 9 285K. So these CPUs are unlocked, so they'll only be replacing the unlocked CPUs from Intel's 14th gen lineup, such as the i5 14600K, i7 14700K, and the i9 14900K. So this is a review, and this review will be comparing the productivity performance, the gaming performance, integrated graphics performance, and power consumption, and lastly also just touch a bit on the temperatures. For the test system, we will be using 3 test systems for benchmarking. The Intel Ultra CPUs will be tested with 8000 mega transfers RAM, and AMD will be using 6000 because that's the sweet spot for AMD. Intel 14th gen, on the other hand, it couldn't run super stable on 8000, and we only could get it to run stable at 7002. So it will be set at 7002 for Intel 14th gen. We also had to set the RAM to 7200 during the integrated graphics tests because there was some issues found during integrated graphics testing. We actually encountered artifacting with the Intel Ultra CPUs. So when the speed is above 7002, such as 7004, 7006. Intel mentioned that this issue will be resolved later on with a BIOS update and a Windows update. But for now, the iGPU benchmarks you'll be seeing will be running at 7002 mega transfers. Let's start off with the productivity benchmarks. The first one will be Cinebench 2024 multi-core. So as you can see in the chart, the Ultra 9 285K takes the crown, leading with about 10 to 15% improvements over Intel 14th gen. So 10 to 15% will be across the lineup. So however, for single core performance, AMD Ryzen 9000 is actually leading the charts, while Ultra CPUs actually show a slight dip in performance, likely due to the reduced P-core frequency. For the next benchmark will be Corona 10. The Ultra CPU show roughly a 2 to 12% performance uplift over 14th gen, but AMD's Ryzen 9950X tops the chart with 14.6 million points. So next will be Handbrake. So Handbrake, there will be 3 parts to Handbrake: H.264, H.265, and AV1. For H.264, the Ultra CPUs deliver roughly around 5 to 14% boost versus 14th generation CPUs. Whereas H.265, it shows roughly about a 7 to 21% improvement in performance. And for AV1, the performance is a bit less at 7 to 11% improvement. Still improvement though. However, AMD side, the Ryzen 9950X still beats the Ultra lineup by an average of 11% across these benchmarks. So the only one that's a bit of an exception would be the 7800X3D. For next benchmark, we have Puget Bench Premier Pro. So we observe 6 to 17% performance drop when comparing Ultra CPUs to 14th gen. So unfortunately, there's a drop. Same goes to DaVinci Resolve. There's a 2 to 5% dip as well. So in both cases, both of these benchmarks, Ryzen 9950X is leading the chart. For 7-zip, so 7-zip has compression and decompression. So the Ultra CPUs generally perform worse by about 6 to 13% in compression, and actually a very significant 17 to 24% drop in performance for decompression. So this is a bit of a letdown. On the other hand, the 9950X from AMD takes a 12% lead in compression and 32% lead in decompression when you compare it to the Ultra 9 285K. So now let's move on to the gaming performance. So gaming performance is a bit interesting, but keep in mind we didn't test any of these Ultra CPUs with Intel's APO or Intel Application Optimization, so the performance might be slightly lower than expected. So first up would be one of the more popular AAA games called Black Myth Wukong. All of these games are running at 1080p. The Ultra CPUs kind of fall behind with a 12 to 27% performance drop as compared to 14th gen. This makes it worse than 14th gen and also AMD chips as well. On the other hand, just take note, all the games are sort of stuck at about 180 FPS because they managed to reach a GPU bottleneck even at 1080p high settings. So scaling is limited after that point. Next, we have the Cyberpunk 2077. In this game, you can see a 6 to 9% performance drop when you compare it to 14th gen, unfortunately. For Shadow of the Tomb Raider, it's a bit of an older AAA title. The Ultra CPUs also lag behind by roughly 5 to 16%, while the 7800X 3D dominates the chart with impressive 371 average. So showing that X3D is highly favored in this game. So the next game would be Final Fantasy 14. Dawn Trail. So this is a popular MMORPG game. Unfortunately, the Ultra CPUs also perform 11 to 16% worse than 14th gen, with Ryzen 9000 actually taking the top of the charts this round compared to the X3D CPUs. So next will be Counter-Strike 2, a FPS esports game. The Ultra CPUs show a 17 to 24% drop compared to the 14th generation lineup. Lastly, we have Dota 2, a MOBA esports game. The Ultra CPUs are at the very bottom of the chart, being 23 to 25% slower than the 14th gen counterparts. So if you see most of the charts, the 7800X 3D is actually at the top of the charts most of the time, taking the performance crown. So moving on, we have the integrated graphics. So for the integrated graphics performance, in this section, we'll focus mainly on the mid of the line for like i7, Ultra 7 and Ryzen 7 chips, because the performance doesn't actually vary very much across the CPU tiers. So in CS2, the Ultra 7 actually achieves impressive 142 FPS, which is 2 times faster than i7 and about 1.9 times faster than the Ryzen CPUs. So in Dota 2, the Ultra 7 is actually about 1.8 times faster than the i7 and about 2.2 times faster than Ryzen. And last, we have Genshin Impact, also a very popular game. Overall, in terms of integrated graphics, it's showing a consistent 2x or above improvement, which is a massive leap from Intel's previous generation. Next will be the power usage. So based on the previous performance that we've seen from the graphs, it wasn't that impressive. Most of it was a slight improvement or a drop in performance. But the question is, has the power draw actually improved? Has the efficiency improved? Starting with the productivity tasks. So for Handbrake H.264, power consumption actually dropped by about 1.1 to 1.5 times compared to Intel's 14th gen. On the other hand, for AMD, the 9950X actually uses 8% less power, while the 9700X actually uses 2 times less power. Although the performance is actually pretty low on the Ryzen 7 compared to Ultra 7. So in Premiere Pro, the Ultra CPUs are actually about 1.6 to 2 times more power efficient than the 14th gen counterparts. And the Ultra CPUs also consumes 5 or 57% lower power when compared to 9700X and 9950X respectively. AMD's 7800X 3D uses 16% less power, showing that it is extremely efficient in this test. In gaming, so let's start with Black Myth Wukong. So Ultra CPUs use about 2.1 to 2.9 times less power than 14th gen and 1.5 to 2 times less power than Ryzen 9000. Even the 7800X 3D has 9% higher power usage versus the Ultra 7 265K, albeit with a higher frame rate. Next, we have Counter-Strike 2. The Ultra CPUs use about 2 to 2.6 times less power than the 14th gen. Ryzen 9000 CPUs also draw about 50 to 60% less power, while the 7800X3D uses about 12% more power. Let's now take a look at the power draw at medium loads. So just now there was power draw at maximum full load, so now it's medium loads. So for example, we'll be using Genshin Impact. Genshin Impact is a popular game that it's locked to 60 FPS. So this is a key point. With this game running, we'll be able to see how much power all these CPUs use when they are playing a game when it's locked to 60 FPS. So the Ultra CPUs only sip roughly around 34 to 38 watts of power when running Genshin. This is very incredible power efficiency, as the previous 14th gen CPUs pull roughly about 86 to 88 watts of power in this same test. So this is a 2.5 times increase in efficiency for medium gaming loads, which is actually pretty insane. Ryzen fared slightly better than 14th gen, but not by much. So only the 7800X3D got close, but none were really able to match the efficiency of the new Ultra CPUs at medium loads. So last, we have the integrated graphics. There's also a significant improvement. For example, CS2, i7 used roughly about 2.2 times more power compared to Ultra 7, while actually performing 2 times worse. So this is efficiency of about 4.4 times improvement. Ryzen 7 also used about double the power, and even the X3D used about 40% more power, while performing worse than the Ultra 7 CPU. So next, we'll be talking about the temperatures that we observe during testing. So thanks to the improved efficiency of the Ultra CPUs, temperatures are actually significantly lower. So for example, in Black Myth Wukong, Ultra CPUs run about 9 to 19 degrees cooler than Intel 14th gen, while Ryzen is about 9 to 15 degrees hotter than the Ultra CPUs. So under full load in Handbrake H.264, the Ultra 5 runs about 16 degrees cooler, and the Ultra 7 about 8 degrees cooler than the 14th gen counterparts. However, Ultra 9 ran about 3 degrees hotter than the i9. We're not sure why, since the power consumption is actually lower in this case. So the 7800X3D runs hotter also because the X3D cache causes the heat to be dissipated less effectively, while the 9700X that doesn't have this cache actually only runs at 57 degrees in this benchmark. So this drop in temperature means that you can either enjoy lower temps with the same cooler, or you can use a slower fan speed, or save some money and get a cheaper cooler, as the cooling requirements have actually dropped. So to conclude this review, Intel is clearly taking a new path or direction with the Ultra CPUs, focusing on higher efficiency and a lower power usage over pure performance. So while some productivity applications see a slight improvement in performance, gaming performance has dropped slightly, with the main benefit being significant reductions in power consumption and lower temperatures. So we may revisit gaming performance with APO and updated drivers in the future. So there's gonna be some room for improvement in the future. And the integrated graphics performance, on the other hand, is really impressive. And these CPUs make an excellent choice for those looking to build a powerful system without a dedicated graphics.